In this video, we're going to go through the 12 core skills that you need to master, normally for paper 1 in chemistry. These skills can appear on either exam that you're faced with, and they are sort of integral and sort of underpin everything else. So mastery of each of these skills is really, really important. If you haven't already attempted this sheet by yourself first before looking at the video, I'd encourage you to work through it by yourself first to see sort of how far you can get and use this to audit the skills that you need to go back and spend longer time looking at. Okay, so without further ado, the first skill is the ability to use the periodic table accurately and interpret the information on it. So the first question is being able to determine the number of protons, neutrons and electrons in each of these examples. So in these 3 examples, each of these are ions. So you need to identify first the 2 numbers. The smaller of the 2 numbers is always the number of protons. So chlorine here has 17 protons, for example. The larger of the 2 numbers is the mass number. And so the mass number is the number of protons and neutrons added together. So you always just take the large number, take the small number from the large number, which in this case would give us 20. So 37 minus 17, that tells you the number of neutrons. Now, in an atom, the number of electrons would always be the same as the number of protons. Now, none of these 3 examples are atoms, they're all ions, and that means they've gained or lost electrons. So if it's a minus, then that means it's gained a negative charge, it's gained an electron. So if there are 17 protons, that must mean there are 18 electrons in that first example. If you weren't sure how to do the second 2 examples, I would pause the video and have a quick go at doing those 2 now, and then you can check, okay? So in terms of the number of protons here, we would have 23. The number of neutrons is going to be 51 minus 23, so obviously 28. And the number of electrons, in this particular case, if it was an atom, it would be 23, but it's got a charge of +5, and that means it's lost 5 electrons, and so that would leave us with 18 electrons here. In the case of scandium, the number of protons is 21, the number of neutrons is going to be 24, and the number of electrons, again, it's +3, so that means it's lost 3 electrons, so again, would also be 18. Next, we identify elements on the periodic table based on other information. So the period is obviously how many shells there are, and the group is how many electrons are in the outer shell. If we look at the periodic table, period 1 only contains hydrogen and helium, period 2, period 3, period 4, and we're going to group 5. So the element that we would be looking for here would be arsenic, which has AS as its symbol notation. The electron configuration, 286, understand how this relates to the information above. So the 6 here relates to the group, because that's the number of electrons in the outer shell, and the period relates to the number of shells. So there are 3 shells because there are 3 numbers. So I could look for group 6 and period 3. So if I do that, period 3 and group 6, I will find that sulfur is the element that we're looking for here. Another way you could deal with this question is just add up the total number of electrons, which is obviously 16, and that's in an atom of sulfur. That would also be the same as the number of protons, and you can see that sulfur has 16 protons here. Okay? The last question is a variant of this, 3 shells and 2 valence electrons. So again, shells will relate to period, and valence is just a fancy word for outer electrons. So we're looking for 3 shells, so period 3, 2 valence electrons, so this last one would be magnesium. Okay, so that's the skill of using the periodic table. The next skill is working out relative formula mass, which is important for other calculations later on. This is as simple as finding the mass numbers on the periodic table and adding them up. So here we have 2 atoms of rubidium, 1 atom of carbon, and 3 atoms of oxygen. So if you look on the periodic table for rubidium, carbon, and oxygen, and look at the mass of each of them, so rubidium is in group 1 here, and we can see that it is 85.5. Carbon is 12 and oxygen is 16. I have 2 rubidiums and I have 3 oxygens. So when I add all of that up, we have 85.5 times 2 plus 12 plus 16 times 3. And that gives me a total molar mass of 231 for rubidium carbonate. The next example is it's slightly different because it's a full displayed formula. So we can see we actually have carbon here twice. So if I group all of the atoms together, I could write this as C2H4O2, which just might be an easier way of kind of counting this up. And so we're going to do 12 times 2, which is for carbon, 1 times 4 for hydrogen, and 16 times 2 for oxygen. And so when we add all of that up, we get 60. Okay, that's the answer for the second one. The last example has the bracket involved, and so we have to work out the ammonium first. So nitrogen has 14 on the periodic table, which you can see here, and hydrogen is obviously 1. So the ammonium is obviously 18. But because that's in brackets, we've got 3 lots of that. So we need to do 3 times 18. That's our first bit. So the 3 ammoniums combined add up to 54. And then we add for phosphorus, which is 31. And add 16 times 4 for oxygen. And that gives us 149. So working out molar mass is an important prerequisite skill, but you are just ultimately adding up the masses. The next skill is working out formulas of compounds, okay? So the basic rule here is that the overall charge must cancel. So we find strontium on the periodic table, which is here in group 2, and any element in group 2 will form a +2 ion. So strontium is going to be strontium +2. Hydroxide is one of the 5 polyatomic ions that we ultimately must learn. So in that case, it's going to be OH minus 1, okay? And to work out the formula, you just swap the numbers around. So it's going to be strontium 1, and then hydroxide, because it's polyatomic, we put it in brackets, and we put a 2 on the outside, okay? Ultimately, you don't have to write the 1, but that would be the formula of strontium hydroxide. Iron 2 phosphate, again, phosphate is one of the polyatomic ions that you should be aware of, which is PO4 3-, and because it tells us specifically that iron has a +2 charge here, because it's iron 2, those would be our numbers. So again, we swap them, and we would get iron 3, and in brackets again for our polyatomic ion, and we put the 2 on the outside. So that would be iron 2 phosphate. And just on the last one, notice the ending is "-ide", not "-ate". So that just means this is nitrogen on its own. So aluminium is in group 3, and so forms a +3 charge. Nitrogen on its own is in group 5, and so nitrogen forms a -3 charge. So when you swap the numbers, you get Al3N3, and because they're equal as a ratio, actually this is just ALN is the final answer, because you can simplify it. Next is we combine these skills to complete like full balanced equations and obviously full formula. So first we're being tested on the combustion of ethanol, so you should recognize the formula of ethanol. So eth meaning 2, so it's C2H5OH. That's one of the simple alcohols that you should be aware of. And for combustion, we react with oxygen and we form carbon dioxide and water. Okay, so then obviously in terms of the balancing of this, you can see we have 2 carbons, we have 6 hydrogens, and we currently have 3 oxygens. So if we account for the 6 hydrogens, we would have H2, and so we need 3 H2. Obviously currently that's 3 oxygens. We've got 1 carbon here, obviously the 2 there, so I need to put a 2 there. So in total, that now gives me 3 oxygens here, 4 here, so a total of 7 oxygens. 1 is in this compound, and so the other 6 have to come from the oxygen. So that is the correct balancing for combustion of ethanol. Next is thermal decomposition of copper carbonate. Again, working out the formula of copper carbonate is something you should be able to do, because copper is a transition element, so unless you're told otherwise, its charge is +2, and carbonate is one of the polyatomic ions we should know. So C2O3 minus 2, we swap the numbers, and obviously that just gives you the formula of CuCO3, okay? Thermal decomposition means it doesn't react to anything else, it just breaks apart due to heat. And when in thermal decomposition, you should know that it breaks apart into the metal oxides, in this case copper oxide and carbon dioxide, and that is already balanced, so we don't need to do anything else to that. just recognizing that type of reaction. So knowing how to balance and types of reaction is important as prerequisite knowledge. So those are the first 4 skills, okay? In the next video, we will cover the next 4.